Have you ever felt like you're just constantly playing catch up with the internet? Like, just when you finally get comfortable with how things work, some new term pops up promising to, revolutionize everything.
Happens all the time.
Exactly. And today, that term is Web3. It's been whispered, shouted, praised, and yeah, derided across pretty much every corner of the internet.
It definitely gets strong
It
reactions.
does. And if Web 2.0 kind of left us feeling like we'd maybe traded our privacy for convenience, well, Web 3 is promising to give us our digital sovereignty back. But is this truly the internet's next evolution? Or is it just, a new layer of complexity we don't really need?
That's the million-dollar question, isn't it?
What is it really? And maybe more importantly, what does it actually mean for how you, our listener, interact with the digital world? Especially when it comes to something as fundamental as, say, finance.
Yeah, that's a fantastic way to frame our deep dive today. Because the sources we're looking at, they range from a really in-depth analysis by the Federal Reserve Bank of Atlanta, industry reports from Deloitte, all the way to, well, candid discussions on places like Reddit.
Ah, Reddit. Always candid.
Indeed. And also specialized reports digging into security and environmental impact. They paint a really multifaceted picture. It's not simple.
So not just hype then?
No, not just hype. We're looking at an ambitious vision, definitely. A rapidly evolving technology stack. And yeah, a subject of intense, often really polarized debate.
Okay.
So our mission today is to try and cut through all that noise. We want to distill these varied perspectives into clear, actionable understanding for you. We'll examine Web3's core concepts, explore its truly transformative potential, especially in financial services, but beyond that too.
Right.
But we also absolutely have to confront the significant challenges and criticisms. It's not all sunshine and roses. The goal is so you can understand what it truly means for your digital future.
Okay, let's unpack this then. To really grasp what Web3 is even aiming for, I think we absolutely have to rewind a bit. We need to understand the internet's past, right?
Definitely helps with context.
So take us back to the very beginning. What was Web 1.0 all about? I'm thinking dial-up, static websites. I vaguely remember those quirky GeoCities pages.
Oh, GeoCities. Yeah, that's a perfect image for Web 1.0. We often call it the read-only web. This was roughly, say, 1991 to about 2004.
The early days.
The very early days. This was the foundational era. It gave us the absolute essentials, the building blocks like HTML for structuring content, URL for, unique addresses to find information.
The web addresses we still use.
Exactly. And HTTP for actually retrieving those linked resources. But users back then, they were primarily passive consumers. People were just delighted by simple novelties like sending an email or checking basic news online. Interaction was, well, minimal.
You just looked at stuff.
Pretty much. You browsed, you read, and that was largely it. It was kind of like visiting a vast, slightly chaotic digital library.
And then things changed dramatically. The internet truly exploded, didn't it? Suddenly, we weren't just reading. We were all creating, sharing, connecting. Social media, user-generated content that was Web 2.0 taking over.
Precisely. Starting around 2004 and really defining our internet experience even today, Web 2.0 is the interactive social web. It's characterized by, well, dynamic user interactions, massive amounts of user-generated content, and of course, widespread mobile access.
Smartphones changed everything.
Completely.
Yeah.
And think of the giants that emerged.
Yeah.
Facebook, Google, Amazon. They became these centralized intermediaries, the gatekeepers, really.
Okay.
They store your data, they verify your identity, and they facilitate virtually all our online services, everything from shopping and banking to streaming and just connecting with friends. It brought immense convenience, no doubt, connecting billions of people.
Yeah, it's hard to imagine life without it now.
True. But it also introduced those growing concerns we mentioned about data ownership, about privacy, and about the just immense power wielded by these big tech companies.
Right, the walled gardens.
Exactly. In essence, while you were busy connecting and sharing, you were also kind of becoming the product. Your data was often monetized, sold to advertisers.
Which brings us to Web 3. And that's exactly where Web 3 steps in, promising this really dramatic shift. Here's where it gets, well, really interesting, I think. It's all about taking back that control, decentralizing the internet, and putting you back in the driver's seat, supposedly. What's the core idea behind this third generation?
The absolute core idea is to move beyond that centralized intermediary model, Web3.
Hmm.
It was first sort of conceptualized back in 2013, and the actual term Web3 was coined by Ethereum co-founder Gavin Wood in 2014. But it really gained significant popularity and, crucially, investment interest around 2021.
That's when everyone started talking about it.
Exactly. And it's not just a simple upgrade. It's presented as an aspirational vision. Its primary aim is to replace those powerful central gatekeepers with a decentralized structure, organizing services without needing huge corporations intermediating every single interaction.
Okay, so less reliance on the big guys.
That's the goal. It
Mhm.
strives for decentralization, transparency, and a kind of digital democracy,
Yeah.
moving us towards what people call a read-write-own version of the web, where you don't just have a profile, you have a tangible stake. You own your digital footprint. Hashtag 1.2, the defining features of Web3.
So decentralized, I hear that term constantly. But what does it actually mean in a practical sense? Does it mean there's no central boss calling the shots anymore? And if so, how does anything actually get done? That sounds a bit chaotic.
Yeah, it's a fair question, and you've hit on the absolute central tenet. Decentralized fundamentally means no single entity, whether that's a corporation, a government, or even a powerful individual, controls the entire network.
Okay. No single point of failure or control.
Exactly. Instead, decision-making authority and control are distributed across a vast network of participants, or stakeholders, as they're often called. The aim is for a far more equitable allocation of power than what we see in Web 2.0.
Hmm.
Think of it less like a company with a CEO and a board, and more like a community where, ideally, everyone has some say, governed by predetermined rules, often embedded in code.
Governed by code.
Often, yes. And a key characteristic of most Web3 projects is that they are open source. That means their underlying code is publicly available, anyone can inspect it, anyone can verify it. This fosters innovation because people can build on top of existing projects.
Makes sense.
But it also means, and this is important, that any vulnerabilities in that public code can, unfortunately, be found and exploited by bad actors.
Ah, the downside.
There's always a trade-off. Furthermore, interactions are often pseudonymous. Users can participate without necessarily needing to reveal their real-world identity. Services aren't always conditioned on knowing who you are personally. And all these interactions, importantly, happen through digital assets, or what we call tokens.
Okay, so if there's no central authority running things, and people might be pseudonymous, how do we trust that transactions and interactions are legitimate? That sounds like it could be chaos waiting to happen without, say, a central bank or a government agency verifying things.
That's where these core principles of trustless and permissionless come in. They're really foundational to how Web3 is supposed to work. Trustless doesn't actually mean there's no trust at all.
Okay, good.
It means you don't need to place your trust in a third-party intermediary like a bank or a platform. Instead, trust is built into the technology itself, primarily through cryptography and the transparent, verifiable nature of blockchains. You trust the math and the code, not a corporation's promise.
Trust the code.
Right. And permissionless means anyone can participate without needing authorization from some governing body. You don't need to ask permission to build an application or to make a transaction or just to join the network. It's designed to be truly open access.
That does sound like a really big deal for my digital life, this whole idea of actually owning my data and my digital assets instead of platforms like Facebook or Google essentially owning them. Is that genuinely possible? Is that the goal?
It's absolute, the central promise, yes. And it fundamentally tries to reconfigure how ownership, data sharing, participation, even self-expression work online. Web3 promises that users will have a real financial stake in and more direct control over the web communities they belong to.
So moving beyond just being a user.
Exactly. Instead of being the product whose data is sold, you become a co-owner, a participant who can benefit directly. This is that shift from the read-write internet of Web 2.0 to a read-write-own internet, where your digital creations, your online identity, even your social graph could theoretically belong entirely to you. And at the very heart of enabling this vision, you have blockchain technology and these token-based economics. They're the engines driving Web3. Cryptocurrencies, or more broadly tokens, are the foundational elements. They're used for secure value transfer, information exchange, and also for providing economic incentives within the ecosystem rewarding participation, for instance.
Right, the incentives.
Crucial. And blockchains themselves provide that transparent, immutable, and auditable means for tracking decisions and verifying adherence to the established rules. It's essentially a tamper-proof digital ledger that everyone can see, but no single entity can easily change. But Web3, or the vision for it, is also much more than just blockchain. It envisions a deep integration of other cutting-edge technologies, too. We're talking about machine learning and artificial intelligence for smarter, data-driven decisions and automating processes.
AI is everywhere now.
It is.
Yeah.
And also things like AR, VR, augmented reality, and virtual reality to create these highly immersive digital environments. The metaverse concept fits in here. So it's not just about decentralizing the back end. It's also about building a truly intelligent, interactive, and hopefully more intuitive internet experience on the front end.
Okay, you mentioned blockchain quite a bit. We hear that word a lot, usually in the same breath as Bitcoin. But is it just Bitcoin? Or is there a whole universe of different blockchains out there doing different things?
Oh, far from just Bitcoin. While Bitcoin was the absolute pioneer, the first mover, there are now well over 200 distinct blockchains currently in operation. Each is designed with unique characteristics, maybe different speeds, different consensus mechanisms, different goals, but they all generally aim to be economically self-sufficient and, ideally, operate reliably in perpetuity.
Wow, over 200.
Yeah, it's a crowded space. We generally categorize them into two main types: public blockchains and private, or sometimes called permissioned blockchains.
Okay, public versus private, what's the difference?
Public blockchains like Ethereum, which is probably the most well-known after Bitcoin, are truly open. They are publicly accessible, universally observable, meaning anyone can see the transactions in the code, and they're typically open source. Anyone can join without needing permission. They have very low barriers to entry.
Like the public internet itself.
Good analogy. Ethereum, for instance, is often described as a kind of publicly accessible and universally observable computer. It doesn't just store transaction data like Bitcoin. It stores and executes complex programs, which we call smart contracts. These public chains, because they're so open, have been the primary drivers of innovation in areas like decentralized finance or DeFi.
Okay, and private chains.
Private or permissioned blockchains are different. They restrict access. Only participants who have been pre-verified, usually off-chain, can join and interact. These are typically focused on institutional or enterprise use cases. Think of blockchains like Corda or Hyperledger Fabric. Their consensus mechanisms, how they agree on the state of the ledger, are often less about global independent verification and more about agreement among a known, trusted group of parties.
More like a private network for businesses.
Exactly, like a private club versus a public park. And just to give you a sense of the scale of these public chains, as of April 2023, Ethereum was leading the pack with around 753 active protocols running on it and a total value locked, or TVL.
TVL? What's that?
Good question. TVL, total value locked, is basically the total amount of crypto assets that have been deposited into a blockchain's decentralized applications. It's a key metric for measuring activity and trust in an ecosystem.
Okay, so a measure of how much money is playing in that sandbox.
Pretty much, yeah. And Ethereum's TVL back then was over $28 billion. Other significant public chains included Binance Smart Chain, Polygon, Arbitrum, and Avalanche, all building out their own vibrant ecosystems with billions locked as well.
You also mentioned tokens earlier as being fundamental. Are they all just cryptocurrencies like Bitcoin and Ethereum? Or is there a broader meaning to the word token in the Web3 context?
That's a really great distinction to make. Well, token and cryptocurrency are often used interchangeably, especially when talking about digital money like Bitcoin. In Web3, a token is actually a much broader concept. Fundamentally, it's a piece of code residing on a blockchain that signifies ownership or control of some kind of asset. And this asset could represent a vast array of things. It could be copyright for a piece of digital art, access rights to an online community, voting rights, and one of those DAOs we'll talk about.
Right, governance tokens.
Exactly. Or it could represent proof of past service, or even truly unique digital collectibles. Because tokens are just code, their design offers immense flexibility.
So not just digital cash.
Not at all. We generally see two primary types: fungible tokens and non-fungible tokens, or NFTs. Fungible tokens are interchangeable, just like a dollar bill or a standard euro coin. One Bitcoin is essentially identical to another Bitcoin. The most common technical standard for these on Ethereum is called ERC20. Think of it like a common blueprint for creating digital cash or utility tokens. All ERC20 tokens are designed to be completely interchangeable.
Okay, like regular money.
Right. Then you have non-fungible tokens, NFTs, which exploded in popularity recently. These are unique and non-interchangeable. Each NFT is distinct. They often follow the ERC 721 standard on Ethereum. Their metadata, the data describing the token, automatically retains a public transaction history. This allows for transparent verification of provenance or authenticity, which is especially powerful when linked to a unique digital item. or even potentially a physical object.
Like digital collectibles art.
Exactly.
Yeah.
The benefits of using tokens on a blockchain, whether fungible or non-fungible, are pretty significant.
Yeah.
You get transparency because users can easily verify value transfers on the public ledger. You get auditability because the entire sequence of transactions is immutably stored. And you get computing capability value can be automatically transferred when specific conditions are met using smart contracts.
Okay, that brings us to smart contracts. These sound incredibly powerful, maybe even a bit futuristic. Are they like a digital vending machine for agreements? You put in specific conditions and out comes the agreed upon action automatically.
That's a remarkably apt analogy. A digital vending machine for agreements is a great way to think about it. Smart contracts are essentially programs stored and executed directly on blockchains, with Ethereum being the most prominent platform for them currently.
So they live on the blockchain.
They do. And they are indeed like vending machines, in that a specific input to a contract's address will always generate the same predictable output according to the rules written in its code. They automatically execute the terms of an agreement when predefined conditions are met.
So removing the need for intermediaries sometimes.
That's the key idea. They eliminate the need for human intermediaries, in many cases, streamlining processes, and significantly reducing the potential for human error or bias. It's about achieving trust through code rather than through institutions.
But there must be a catch, right?
There is a critical caveat, yes. Once a smart contract is implemented and deployed on the blockchain, it's largely immutable. It generally can't be easily changed or updated.
Wait, so if there's a bug?
Exactly. If a vulnerability or a bug is discovered after deployment, it's incredibly difficult, sometimes impossible, to patch or fix it. This leaves the contract, and potentially any funds held within it, open to exploitation. This immutability is both a strength ensuring reliability and predictability, and a significant challenge, especially for security.
That sounds risky.
It can be, absolutely. Requires very careful coding and auditing.
So with all this talk of decentralization, smart contracts automatically executing things, and tokens representing ownership or rights, how do we actually run organizations without a traditional central authority? That sounds like it could easily descend into chaos or gridlock. Tell us about DAOs.
Right, DAOs. Decentralized autonomous organizations. They are truly revolutionary in their ambition, aiming to answer exactly that question. They are organizations designed to operate without any central authority whatsoever.
No CEO, no board?
Ideally, no. Instead, their rules, how they operate, how decisions are made, how funds are spent, are encoded directly into smart contracts on the blockchain, and they are governed by a distributed group of governance token holders.
So holding the token gives you a vote.
Typically, yes. These token holders collectively determine the DAO's direction. Any proposed change or decision, whether it's allocating funds from the Treasury, updating the protocol, or hiring contributors, is authorized through votes cast by these token holders. The system aims to provide a transparent and hopefully democratic decision-making process. The goal is to move beyond those traditional hierarchical structures where power is often concentrated at the top and foster a more equitable, efficient, and community-driven form of collective governance. It's a radical experiment in organization building.
Okay, now that we've kind of laid the groundwork, understand the building blocks, let's explore where Web3 really aims to shake things up. And one of its biggest, boldest promises is to make financial transactions cheaper, faster, and maybe more accessible for everyone. How exactly does it hope to achieve that?
Yeah, finance is arguably where we've seen the most concrete development and disruption so far. It's about a complete reimagining of the financial plumbing, really.
The plumbing, okay.
By tokenizing transactions, essentially turning every asset, every payment, every financial instrument into a digital token on a blockchain, and then conducting those transactions directly on that shared ledger, Web3 can dramatically harmonize back-office operations.
What does that mean, harmonize your back office? Less paperwork?
Essentially, yes. Much less need for complex, slow, and error-prone clearing or reconciliation steps between different banks or institutions. Think about all the systems that have to talk to each other after a traditional stock trade, for example.
Right, it takes days sometimes.
Yeah. Exactly. With blockchain, you can have all transacting parties making entries on one common, shared, and instantly updated ledger. It fundamentally streamlines the entire financial process, cutting out layers of intermediaries and manual checks. This directly leads to significantly reduced operational costs and fewer failed deliveries or settlement errors. And a really crucial efficiency gain here is something called delivery versus payment, or DVP. In traditional markets, as you said, there's often a significant time lag days, even between agreeing on a trade and its final settlement. This gap requires complex clearing mechanisms, collateral management, and introduces inherent counterparty risk, the risk the other side won't hold up their end of the bargain.
Okay.
Web3, particularly with smart contracts, can integrate the trade and settlement into a single atomic transaction. That means it either fully happens instantly, with both sides fulfilling their obligations simultaneously, or it completely fails and nothing happens.
All or nothing, instantly.
Precisely. This drastically reduces that settlement lag, along with the associated risks and costs. There's also a really novel benefit emerging. Once minted, these tokens can be highly versatile, almost like programmable Lego bricks.
Programmable money Legos.
Kind of. For example, imagine you provide liquidity to one of those automated market makers we'll discuss. You get back a receipt token proving your deposit. Now, that receipt token itself could potentially be used as collateral for another loan somewhere else in the DeFi ecosystem.
Ah, so your assets can work in multiple places at once.
Exactly. It's called composability. So a liquidity provider facing a sudden need for cash might just transfer their claim token rather than withdrawing their underlying assets from the pool. This could potentially make liquidity provision cheaper and markets more dynamic and liquid overall. It unlocks capital efficiency.
Okay, that sounds like a big theoretical shift in how finance could work. But what are some real-world examples of how this is actually playing out, creating entirely new services for us? What does decentralized finance or DeFi actually look like in practice?
All right, let's get concrete. DeFi has indeed developed some truly novel ways to do things like trade assets, make collateralized loans, and process payments, all without needing traditional financial intermediaries like banks or brokers.
Cutting out the middleman.
That's the mantra. And to give you a sense of its scale again, the sector had a total value locked, or TVL, of over $100 billion across all blockchains back in June 2022. That's a significant amount of activity, showing real user adoption, even if it's still niche compared to traditional finance.
Okay, $100 billion is not small change. So what are these DeFi services?
Let's look at a few key examples. First, automated market makers, or AMMs. You might have heard of Uniswap or Curve.
Vaguely, yes. Trading platforms.
Sort of, but they work very differently from traditional exchanges. In traditional finance, market makers are typically large institutions that provide buy and sell quotes. AMMs radically separate the job of providing liquidity from the job of price discovery. Anyone can be a liquidity supplier. You deposit an equal value of two different tokens into a swap pool, say Ether and a stablecoin. In return, you receive a liquidity token as a receipt, proving your share of the pool.
Okay.
Now, when you or someone else wants to swap one token for the other, the price is calculated automatically, mechanically, by a formula based on the relative amounts of the two tokens currently in the pool and the size of your desired trade. Larger orders automatically have a larger price impact, similar to how large orders move prices in traditional markets, but it's all determined by the algorithm, not a human market maker.
Interesting. So the price is set by the pool's balance.
Exactly. And protocols like Curve are specially designed for trading stablecoins. Those digital assets pegged to dollars or euros, allowing them to trade very close to 1.1 for most quantities, minimizing the price impact for stable value transfers. Academic studies have actually shown that these AMMs can provide deep and efficient markets, with their prices often aligning very closely with major centralized exchanges.
Okay, so automated trading pools. What else?
Second big area, collateralized lending. Think of large lending protocols like Compound or AAVE. These aren't banks in the traditional sense.
Right.
Here, lenders deposit their crypto tokens into a smart contract pool and start earning interest. They receive a receipt token representing their deposit. Borrowers, on the other hand, deposit collateral, usually other cryptocurrencies, into the protocol. Once their collateral is locked, they can withdraw another token as a loan, up to a certain percentage of their collateral's value.
So borrowing against your crypto.
Precisely. The systems are designed to mitigate credit risk through over-collateralization. You have to deposit more value than you borrow. Loans are typically floating rate, similar to repurchase markets in traditional finance, with interest rates adjusting automatically, sometimes block by block, based purely on the supply and demand for that specific token within the pool.
What happens if the collateral value drops, like in a market crash?
Great question. That's where automated liquidations come in. If the value of your deposited collateral falls below a certain threshold, the smart contract automatically allows third-party liquidators to repay a portion of your loan and seize a corresponding amount of your collateral, usually at a slight discount, to ensure the system remains solvent and lenders get paid back. It's designed to be automatic and remove counterparty risk.
Sounds efficient, if a bit brutal for the borrower.
It can be, yes. requires careful risk management. And these protocols are big. As of April 2023, Aid alone had over $5 billion in TVL operating on 7 different blockchains, showing its reach.
Okay. What about just payments, moving money around?
Third key area, making payments, especially with stablecoins. Early on, a big problem in crypto was the lack of a stable unit of account. Everything was volatile. Plus, getting money from the traditional financial system into crypto and back out again, the on and off ramps, was difficult. This led to the rise of stablecoins.
The digital dollars.
Right. Digital assets designed to maintain a stable value, usually pegged 1.1 to fiat currencies like the US dollar or the euro. They've become absolutely crucial as a means of payment, a unit of account, and safe collateral within the DeFi ecosystem.
How do they stay stable?
Well, there are different types. The largest ones are fiat-backed, like Tether, USDT, USD Coin, USDC, and Binance USD, BUSD. They're supposed to hold equivalent reserves in traditional assets, like cash and short-term government debt, although the quality and transparency of these reserves have faced intense scrutiny and controversy.
Yeah, I've heard about Tether's issues.
Exactly. Tether had a settlement with the New York Attorney General over reserve misrepresentations, and USDC briefly lost its peg when Silicon Valley Bank collapsed because Circle, the issuer, held some of its reserves there. So fiat backing isn't foolproof.
Okay, other type.
There were also crypto-collateralized stablecoins, like DAI, which is generated by the MakerDAO protocol. DAI maintains its peg using a system of over-collateralization with other cryptocurrencies like Ether, managed by algorithms and governance votes. And then there were algorithmic stablecoins, like the infamous Terra UST, which tried to maintain its peg using complex algorithms and arbitrage incentives without direct collateral, and which spectacularly collapsed.
Right, Terra Luna, that was huge.
A massive failure, highlighting the risks. But where stablecoins show huge potential is in international remittances. Sending money across borders traditionally involves high fees. The World Bank reported average costs of about 6% for sending $200 in 2022. Decentralized exchanges using stablecoins could lead to substantial cost reductions, potentially up to 80% in some corridors.
Wow, 80% cheaper.
Potentially, yes. This could be a massive benefit, addressing issues like the high cost of correspondent banking and the declining number of traditional banks willing to service certain regions, particularly in developing nations.
That could be genuinely impactful.
Agreed. Fourth area, making assets more liquid through tokenization. Think about how many valuable assets in the world are historically very difficult to trade quickly or easily. Massive infrastructure loans, commercial real estate, fine art, even legal rights. Finding a buyer, transferring ownership is slow, expensive, and full of friction. This illiquidity typically depresses the asset's price.
Right, you pay a premium for liquidity.
Exactly. Web3 offers a powerful potential solution, tokenization. Theoretically, almost anything can be tokenized, turned into a digital token on a blockchain. Copyrights, access rights, voting rights, unique collectibles, physical real estate, precious metals, intellectual property, you name it.
How does that help?
Tokenization enables things like fractional ownership. You could own, say, 0.01% of a commercial building or a famous painting. It significantly improves record keeping, making ownership transparent and easily verifiable. And it makes these assets potentially much more easily tradable on secondary markets, Token 47 globally, with lower transaction costs. Companies like Tokeny in Luxembourg are already specializing in regulatory-compliant tokenization solutions, and private blockchains like Provenance are focusing on managing tokenized fixed-income assets. This could lead to more efficient and transparent securitization processes, and through the automated margin enforcement we see in DeFi, potentially even reduce credit risk compared to traditional finance.
Turning everything into tradable tokens. Interesting. Anything else on the finance side?
One more interesting development, improving domestic payments with digitized deposits. This is kind of an interim solution, sitting somewhere between private stablecoins and fully centralized central bank digital currencies, or CBDCs, which we'll discuss later. Digitized deposits are already operating in some places.
How do they work?
The USD Forward Consortium, for example, uses the permission provenance blockchain. Participating banks can tokenize their actual customer deposits. So the money is still held at the bank, fully regulated, but it's represented as a token on the blockchain.
Okay. What's the benefit?
These digitized deposits allow for real-time, programmable payments between customers of participating banks using the efficiency of the blockchain. It gives banks the flexibility to issue their own digital inside money on a modern rail. Customers interact with the blockchain indirectly through their existing bank, which mints and burns these deposit tokens for them. This model is gaining global interest. The Swiss Bankers Association has also proposed a similar deposit token for the Swiss franc. It hints at a future where our regular bank accounts themselves might actually be running on some form of blockchain technology. #Tag 2.2 broader Web3 use cases and societal benefits.
Wow, that's a really comprehensive look at the potential in finance. But Web3 isn't just about money and trading, is it? What about how we interact online more generally? You mentioned the read-write-own idea. Imagine actually owning your social media data, maybe even being compensated for it, rather than just being the product sold to advertisers. That sounds truly revolutionary for everyday users like me.
Absolutely. And this critique of the current Web 2.0 social media model is widespread and, frankly, pretty valid. It's often described as exploitative. Your personal data, your behavior, your connections, they're indiscriminately harvested, analyzed, and packaged up to be sold to advertisers, and you typically get nothing tangible in return except access to the platform.
Yeah, free isn't really free.
Exactly.
Yeah.
Web3 offers a stark alternative vision here. It aims to give users much more granular control over what data they choose to provide. And potentially it allows for models where users are directly compensated, maybe in cash, maybe in crypto, maybe in the platform's own native tokens, for their attention, their contributions, their data. This fundamentally changes the user from being a passive product into an empowered participant, maybe even a stakeholder.
Are there examples of this actually happening? It's still early days, but yes, experiments are happening. Companies like Betaku were early pioneers trying to compensate internet users directly for their data. And we're seeing blockchain-based social platforms emerge, like Sapien, built on Ethereum, which aims to give users significant control over their data and offers token rewards for engagement. Another example is Steemit, which automatically distributes rewards to content creators and curators in its own smart media tokens. Platforms like SocialX also aim to reward users in their native cryptocurrency. It's a definite trend. Beyond ownership and compensation, the decentralized nature of Web3 offers another powerful benefit: censorship resistance. Once a truly decentralized application, or DApp, is deployed on a public blockchain, it's virtually impossible for any single entity, a company, or a government to simply remove or delete it. Unlike an app that can be pulled from Apple's App Store or Google Play at their discretion. That sounds huge for free speech.
It's incredibly important. We've seen journalists and activists, especially in countries with limited press freedom or authoritarian regimes, turning to blockchain-based protocols and decentralized hosting services like Arweave to publish information that might otherwise be blocked, censored, or deleted. It provides a more resilient platform for dissent and truth-telling. And this empowerment extends directly to content creators, too. Think about the current Web 2.0 model. Platforms like Facebook and Instagram offer basically zero direct compensation for the content that drives their engagement. YouTube, while better, can take 50% or even more of the advertising revenue generated from a creator's videos, and they often control a creator's reach or can demonetize content based on opaque or shifting rules, often without clear recourse.
Yeah, creators complain about that all the time. The algorithm changes, demonetization.
Exactly. Web3 introduces entirely new monetization methods. Things like tokenizing content, selling unique digital versions as NFTs, allowing creators to connect directly with their audience, retaining full ownership of their work, and potentially earning perpetual royalties through smart contracts automatically baked into their digital assets whenever they're resold.
So, ongoing income from secondary sales.
Potentially, yes, if coded into the NFT smart contract. This means artists and creators could potentially generate a sustainable full-time income from a smaller, more dedicated fan base, maybe just 1,000 to 10,000 true fans, whereas previously, in the Web 2.0 model, they often needed hundreds of thousands or even millions of user followers to make a comparable living. It's a radical shift towards a true creator economy, cutting out many of the traditional intermediaries.
Okay, that's compelling for creators. What about organizations themselves? We talked about DAOs. Can they truly make organizations fairer and more efficient than traditional companies, which, let's face it, often seem laser-focused on maximizing shareholder value above everything else, sometimes leading to questionable decisions?
That's the hope and the hypothesis behind DAOs. Traditional centralized corporate models often suffer from well-documented issues. Sometimes inefficient or bureaucratic management, perceived unfairness in compensation structures, and that aggressive, often short-term focus on shareholder value, which can potentially stifle long-term innovation and even lead to ethical compromises.
Right. Quarterly earnings pressure.
Precisely. DAOs, by operating on those transparent blockchain-based smart contracts and being run, theoretically, by a distributed group of governance token holders, promise greater democratization and efficiency. They enable collective decision-making, where community members, the token holders, vote on proposals, manage resources collectively, and ideally foster transparency, accountability, and more equal participation.
But does it actually work? Do people participate, or do the big token holders just dominate?
That's a very real challenge, and one DAOs are actively grappling with. Voter apathy can be an issue, and the risk of power concentrating among large token holders, whales, is significant. However, DAOs are evolving and experimenting with governance mechanisms to address this. For example, Optimism, which is a popular Ethereum Layer 2 scaling solution, has implemented a fascinating bicameral or two-house governance structure.
Two houses, like a parliament.
Kind of. They have a token house, where voting power is based on the number of tokens held, essentially one token, one vote. But they also have a separate citizens house, where voting power is based on holding a special, non-transferable NFT, often called a soul-bound token, which represents a unique identity or contribution within the ecosystem. The goal here is to achieve something closer to one person, one vote, alongside the token-weighted voting, trying to balance plutocratic tendencies with a more citizen-centric approach. It's an ongoing experiment. Moving beyond governance, Web3's development is also deeply intertwined with creating highly realistic VR and AR environments, the whole metaverse concept. This technology has wide-ranging potential benefits, far beyond just gaming or entertainment.
Like what?
For businesses and individuals, it could greatly improve career training and education. Imagine highly realistic medical and surgical simulations where trainees can practice complex procedures without risk, potentially reducing the need for expensive physical models or even cadavers in some cases.
Oh, okay.
It could also bring remote workers together physically for immersive virtual meetings, collaborative design sessions, or even just social gatherings, helping to bridge geographical distances and foster team cohesion in ways video calls can't.
Virtual water cooler chats.
Exactly, but more immersive. And, perhaps more profoundly, AR/VR in a Web3 contest could provide entirely new social and career opportunities for disabled individuals. Imagine allowing someone with mobility impairments full freedom of movement within a virtual space to perform physically oriented jobs, like architectural walkthroughs, or to teach skills like yoga or dance virtually, embodying movements they can't physically perform.
That's incredibly powerful.
It is. And this technology is likely to be further spurred by advancements in direct computer-brain neural interfaces, like the kind being researched by companies such as Elon Musk's Neuralink. These could, in theory, allow paralyzed individuals complete freedom of movement and interaction within VRR spaces simply by interpreting their brain signals. It's futuristic, but the potential is there. Artificial intelligence, AI, and machine learning, ML, are also seen as foundational components of the broader Web3 vision, bringing more sophisticated human-AI interactions to the forefront. These technologies can significantly enhance the productivity of individual workers, especially when dealing with large data sets. They can assist with basic functions like writing code, drafting communications, or even highly complex tasks like analyzing medical scans or identifying patterns in scientific research.
AI co-pilots for work.
Pretty much. And on a larger societal scale, AI can help tackle some of the world's most pressing problems by analyzing vast amounts of data for scientific discovery, maybe advancing alternative energy solutions, accelerating progress in regenerative medicine or genetic engineering, or even optimizing models for space travel. It could also potentially generate more advanced economic models to help combat poverty or predict and prevent future financial crises. And the power of AI could become exponentially greater when combined with the potential of quantum computing, which promises to process certain types of information millions of times faster than even the most powerful classical supercomputers we have today. It's a convergence of powerful technologies.
This all sounds like a complete overhaul of not just the internet, but maybe society itself. Beyond the investment hype, it truly sounds like Web3 is creating entirely new career paths for people, and maybe not just for the super tech-savvy elite.
Absolutely. That's a really important aspect. Web3, alongside the related fields of blockchain, crypto, DeFi, and the metaverse, is genuinely creating a wide variety of new career opportunities across many different skill levels.
Not just coding.
Definitely not just coding. Yes, there's huge demand for highly specialized roles like blockchain engineers and smart contract auditors. But there's also a growing need for writers who can explain this complex stuff, marketers who understand token economics, community managers to foster DAO participation, UX/UI designers to make dApps usable. Often in roles that are better paid and potentially more engaging or mission-driven than traditional counterparts, simply because the field is new and talent is scarce. And as we touched on, NFTs have provided a really effective new method for artists, visual artists, musicians, digital creators to monetize their creative output directly, often bypassing traditional galleries, labels, or platforms that take large cuts.
Right. The creator economy.
That's exactly. Even blockchain gaming, spurred by early play-to-earn games like Axie Infinity or virtual worlds like Decentralized and the Sandbox, has created entirely new careers. There were credible reports of thousands of people, particularly in countries like the Philippines during the pandemic, quitting low-paying traditional jobs to play these games full-time, earning competitive incomes through trading in-game assets and rewards. Now, the sustainability of that specific model is debatable, but it showed the potential. And in an environment of, rising inflation and general financial insecurity that many people feel, cryptocurrencies, despite their undeniable volatility, have offered high growth, albeit high-risk investment options. Bitcoin, with its mathematically fixed supply of 21 million coins, is often seen by its proponents as a potential digital gold, a safe commodity and perhaps an inflation hedge, although that's hotly debated.
Yeah, very debated.
Very debated. But beyond Bitcoin, we're also seeing the creation of new, potentially more stable, inflation-resistant stablecoins. For example, Frax Finance's FPI token is designed to track the U.S. Consumer Price Index. The idea is to offer low-risk ways for savers to potentially hedge against inflation without relying on traditional banking products or exposing themselves to the wild swings of volatile crypto assets. It's an innovative financial product born out of Web3 thinking. And this all ties back to the broader theme of DeFi as an alternative to traditional banking. The legacy banking system often faces criticism for high fees, low interest rates offered to savers, and sometimes aggressive prioritization of shareholder profit over customer benefit. DeFi apps, many operating as those community-governed DAOs, aim to offer innovative financial services, lending, borrowing, trading, yield generation, often at lower costs, with potentially greater privacy due to pseudonymity, and more user autonomy.
Built on those smart contracts we discussed.
It's exactly. Running on auditable smart contracts, aiming for that trustlessness where you rely on the code, not the institution. Again, the scale was significant, $106 billion TVL in DeFi as of June 2022. Projects like the crypto lending giant AADE allow users to take out collateralized loans against their crypto assets, often without needing a traditional credit check. And DeFi is even beginning to tentatively dip its toes into financing real-world assets. There was a notable case where MakerDAO, the protocol behind the DAI stablecoin, provided a $7.8 million loan collateralized by real estate to help finance a Tesla collision repair center.
Wow, bridging crypto and the real world.
Slowly, yes. This has the potential, proponents argue, to provide traditional banking services at significantly lower prices and, crucially, maybe help bank the vast populations, particularly in developing countries who are currently underserved or excluded by the traditional financial system, offering them access to savings, credit, and payments in a new way. That's the big aspirational promise.
Okay, that's a really powerful and, frankly, quite optimistic vision for what Web3 could be. But let's bring it back down to earth. Let's be realistic. So many of these ideas sound amazing on paper, but what's stopping everyone from just jumping in right now? It often sounds incredibly complicated for the average person, just full of jargon and obscure technical steps.
You're hitting on an absolutely critical point, and it's probably one of the biggest barriers to mass adoption right now. The on-ramp to Web3 just getting started is far from intuitive for most people.
Yeah, setting up a wallet alone seems daunting.
It really can be. Getting a crypto wallet, understanding how to securely store your private keys or seed phrase, figuring out how decentralized applications, DApps, actually work, navigating different blockchains. It can be extremely challenging, particularly for anyone who isn't already fairly tech-savvy or what the community calls crypto-native. The user interfaces on many dApps are still quite clunky compared to slick Web 2.0 apps. There's often a lack of clear, simple explanations for what's happening when you make an on-chain transaction. And you frequently encounter multi-step processes that just feel awkward. All of this creates significant barriers to entry and makes mainstream adoption really difficult, even for people who are genuinely interested in trying it out. Then there's another huge practical hurdle: scalability and transaction costs. Currently, most public blockchains, especially the most popular ones like Ethereum's main network, struggle to process transactions at a rate anywhere near comparable to conventional systems like Visa or MasterCard. This can lead to network congestion and delays, especially during peak times.
Things get slow and expensive.
Exactly. And that brings us to the cost issue. A major drawback, particularly on the Ethereum mainnet, what we call Layer 1, is the often incredibly high cost of transactions, known as gas fees. These fees, paid to network validators for processing your transaction, can fluctuate wildly and often range from, say, $35 to $100, or sometimes even significantly higher just for a single simple transaction like a token swap or an NFT purchase.
$100 for one transaction, that's insane for small
It
amounts.
makes small transactions or frequent updates completely uneconomical. It leads many people to reasonably conclude that Web3 in its current Layer 1 form is simply too costly and impractical for everyday use. This lack of scalability and the high cost act as a massive deterrent for both individual users and for enterprises that might need to handle large volumes of transactions or onboard millions of users.
Are there solutions being worked on?
Yes, definitely. There are what we call Layer 2 scaling solutions, separate blockchains built on top of Layer 1s like Ethereum. Things like Polygon, Arbitrum, Optimism. They bundle transactions together off-chain and then settle them more efficiently on the main chain, achieving much higher speeds and dramatically lower costs, often just pennies per transaction.
Okay, that sounds promising.
It is. But
Mhm.
the process of moving your assets from the main Layer 1 blockchain over to these Layer 2 solutions, known as bridging, can itself be time-consuming, sometimes technically complex, and can even incur its own significant gas fees, especially when the main network is congested. So it adds another layer of complexity, particularly for novices. Then there's the nagging issue of interoperability. We have all these different blockchains now: Ethereum, Solana, Avalanche, Cosmos, Polkadot, and hundreds more. But they often use distinct underlying technologies, protocols, and standards. This makes seamless interaction and the easy transfer of assets or data between these different blockchains difficult, sometimes impossible.
So they don't talk to each other easily.
Not natively, no. It creates these fragmented ecosystems, like separate digital islands, which kind of hinders the grand vision of a truly interconnected, seamless, decentralized web. There are projects working on cross-chain bridges and interoperability protocols, but it's still a major technical challenge. And circling back to something we touched on earlier, security concerns for smart contracts and user data remain absolutely paramount. Remember, those smart contracts, once deployed, are generally immutable. That's their strength, but also their biggest security weakness.
Because you can't fix bugs easily.
Exactly. If a vulnerability or a logical flaw is discovered in the code after it's deployed and holding potentially millions or billions of dollars in assets, it's incredibly difficult, sometimes impossible, to patch or update it without a complex and contentious hard fork of the entire blockchain. This leaves it permanently open to exploitation by hackers.
A ticking time bomb, potentially.
In some cases, yes. Furthermore, depending on the design of the blockchain and the specific application, all transaction data might be publicly visible on the ledger. While wallet addresses are pseudonymous, just strings of characters, they aren't truly anonymous. Sophisticated actors, including potentially governments or corporations, can use chain analysis techniques to try and link wallet addresses to real-world identities or track user behavior. If data models within dApps are poorly designed, user privacy can be compromised. Secure coding practices and critically independent third-party smart contract audits are absolutely essential before deploying any significant application. But sadly, they are sometimes overlooked or rushed in the frenzy to launch new projects, leading to catastrophic losses from hacks. Hashtag Tag 3.2 business and regulatory challenges.
That leads us neatly into perhaps the biggest cloud hanging over the entire Web3 space, especially for established businesses and institutions: regulation. How on earth do you regulate something that's designed to be borderless, decentralized, often involves pseudonymous actors, and uses entirely new types of digital assets? It seems like a huge, tangled question mark for anyone trying to build or invest seriously in this space.
It absolutely is, and you've nailed the core challenge. The pervasive lack of clear, consistent, and globally harmonized regulatory guidance is a significant deterrent. It creates immense uncertainty for both end users wondering if their assets are safe or legal, and for large enterprises considering adopting Web3 technologies.
Different countries have different rules or no rules.
Exactly. And even within a single country, like the United States, you have this alphabet soup of different regulatory bodies: the SEC, Securities and Exchange Commission, the CFTC, Commodity Futures Trading Commission, FinCEN, Financial Crimes Enforcement Network, the IRS, the FTC, OFAC, Office of Foreign Assets Control, even accounting standard bodies like FASB and PCAOB, all weighing in, often with different interpretations or jurisdictions.
Sounds like a nightmare for compliance teams.
It is. Comprehensive, definitive guidance remains elusive, and sometimes the guidance seems contradictory. This ambiguity presents the primary regulatory challenge, as the Federal Reserve Bank of Atlanta report put it, when trying to figure out how Web3's entirely new infrastructure fits into existing legal frameworks designed for a centralized world. It's particularly challenging for those decentralized autonomous organizations, the DAOs, because regulators are historically used to engaging with traditional, clearly defined legal entities like corporations or partnerships. Who do you serve papers to in a DAO?
Good question.
While some momentum is building globally, for example, the European Union's Markets in Crypto Assets Regulation, or MiCA, is a significant attempt at creating a comprehensive framework. Progress is slow and fragmented. In the U.S., enterprises often face this difficult dilemma. Do they wait for clarity, potentially falling behind competitors? Do they undertake small, cautious pilot projects? Or do they move forward more aggressively and risk significant regulatory backlash down the line if interpretations change? Another major practical challenge for businesses wanting to adopt Web3 is the lack of skilled talent. The demand for people with expertise in blockchain development, smart contract auditing, crypto economics, even legal and compliance professionals who understand this space has absolutely exploded. We saw jobs in this sector increase dramatically between 2019 and 2021.
But not enough people with the skills.
Exactly. There's a significant shortage of skilled talent available. It's a brand new field, and educational pipelines are still catching up. This poses a major bottleneck for adoption at scale. Enterprises find themselves needing to invest heavily and often expensively in either hiring scarce talent, upskilling their existing employees, or developing in-house training programs just to gain the necessary capabilities. It's a real constraint on growth. And then there are the profound changes required in basic business operations and traditional revenue models. Web3's decentralized nature enables and often necessitates entirely innovative revenue models that can fundamentally disrupt current business frameworks.
Like what kind of models?
Things like raising funds directly from a global community through token offerings, initial coin offerings or ICOs, though those have become more regulated. Selling digital assets like NFTs that grant utility or access within an ecosystem. Earning ongoing revenue from secondary sales of those NFTs through automated royalties built into the smart contract. Implementing real-time revenue sharing with users or contributors via smart contracts, or even generating yield by lending or borrowing digital assets directly on-chain through DeFi protocols.
Sounds very different from selling ads or subscriptions.
Completely different. But these new models also bring incredibly complex and constantly evolving tax and accounting considerations. How do you value these tokens? When is revenue recognized? How do you handle cross-border transactions? The rule books are still being written. Furthermore, the open, permissionless nature of many Web3 applications means customer switching costs can be very low. If a user doesn't like one dApp, they can often easily move their assets and activities to a competing one.
Less stickiness.
Potentially, yes. To attract and retain customers, enterprises often need to continuously provide tangible value, perhaps through token incentives, actively partner with other projects to build network effects, and constantly innovate. New models even allow customers to have a direct voice in the project's governance, or even receive a share of the revenue through owning tokens. But these approaches, while fostering community, also carry significant implications for tax laws, financial crime regulations, like KYCML, and potentially securities law if the tokens are deemed investments. It's a complex web of operational and legal challenges. Hashtag 3.3, skepticism, hype, and real-world critiques. Now, for every passionate Web3 enthusiast evangelizing this new future, it really seems like there's an equally vocal skeptic, often dismissing the whole thing as just, well, overblown marketing hype or a solution looking for a problem. What are the strongest arguments from those who are highly critical of Web3? You're absolutely right. The skepticism is fierce, and it often comes from very influential and technically savvy figures. Many critics, including well-known names in tech like Elon Musk or Twitter block founder Jack Dorsey, have publicly dismissed Web3 as an empty marketing term or even vaporware.
Vaporware, like it doesn't really exist.
Or that the grand promises vastly outstrip the current reality. One common description from critics is that Web3 is a promised future internet that fixes all the things people don't like about the current internet, even when fixing those things is contradictory.
Okay, that's harsh.
It is. The core argument from this critical camp is often that Web3 frequently aims to do things that Web 2.0 already does, but typically does them more expensively, less efficiently, and with a much worse user experience.
Making things harder, not easier.
That's the critique. Critics argue that proponents haven't yet demonstrated many truly compelling use cases, where using a blockchain provides a genuine, significant improvement over existing centralized database systems or platforms. They often describe the pitches for many Web3 projects as elaborate fantasies that ignore practical realities or existing solutions. They constantly ask, why do you need a blockchain for this? And that leads directly into deep concerns about decentralization itself. Is it just an illusion of control? While decentralization is Web3's foundational promise, its core selling point, critics argue that true, meaningful decentralization is often impractical, or worse, just an illusion in many projects.
How so?
Well, the inherent complexity of interacting directly with blockchains often necessitates the use of middleware things, like user-friendly wallets, which themselves might be centralized companies, or Web2-style portals and interfaces that make dApps accessible. These intermediaries can effectively become new centralized points of control or failure, defeating the original purpose.
So you end up relying on central players anyway.
Often, yes. There's a significant concern voiced by people like Jack Dorsey that power doesn't truly get decentralized to the users, but simply shifts from the current big tech giants to a different set of powerful players. Venture capital firms who fund the projects and receive large token allocations, and wealthy individuals or entities who own vast amounts of governance tokens or operate large numbers of validator nodes, node whales.
So power shifts, but doesn't disappear.
Exactly. This risks reducing true decentralization and could actually increase the threat of plutocracy rule by the wealthy, or node collusion, where large validators could potentially conspire to manipulate the network. For instance, running a full Bitcoin node securely requires significant technical know-how and computing resources, often beyond the average consumer. And the high cost of becoming an Ethereum validator, currently requiring 32 ETH, which is well over $100,000, places it completely out of reach for most people, limiting genuine participation in securing the network. Even in DAOs, as we discussed, despite their democratic promise, they can suffer from low voter turnout or effective dominance by the largest token holders, undermining the ideal of broad community governance.
Okay, that's a sobering counterpoint to the decentralization dream. And unfortunately, the headlines often seem dominated by the darker side of this new frontier, the constant stream of scams, hacks, and outright fraud that seem to plague the crypto and Web3 space. How prevalent are these issues, really, and how much has it damaged Web3's overall reputation?
The prevalence is undeniable, and the reputational damage has been immense. The Web3 ecosystem, partly due to its novelty, complexity, and the large sums of money involved, has indeed been fertile ground for financial scams.
Like what kind of scams?
We see everything. Rug pulls are incredibly common, where project creators hype up a token or NFT collection, attract investment, and then simply disappear, abandoning the project and taking all the investors' money with them. We see elaborate exit scams, phishing attacks targeting wallet keys, Ponzi schemes dressed up in crypto jargon, and outright fraudulent projects that never intended to deliver anything.
Sounds like the Wild West.
It often feels like it. This rampant misconduct has led to widespread skepticism and distrust among the general public, who often, understandably, equate all of blockchain and Web3 with these negative aspects. It makes it incredibly hard to have a nuanced conversation about the technology's potential when the headlines are full of people losing their life savings.
Can you give an example?
A particularly stark example was the collapse of the Terra USD algorithmic stablecoin ecosystem in May 2022. It wasn't a direct hack or scam in the traditional sense, but its flawed design led to a catastrophic death spiral, wiping out over $50 billion in investor value virtually overnight. NFT scams are also rampant. The notorious Frosty's rug pull saw creators make off with millions just hours after launching. These incidents aren't isolated. They represent a persistent and sobering reality that significantly undermines trust and makes mainstream adoption incredibly difficult. Another one of the most significant and persistent criticisms, particularly associated with the earlier blockchain technologies like Bitcoin, is the environmental impact, specifically energy consumption. The proof of work, or POW, consensus mechanism the process Bitcoin uses to validate transactions and secure its network, requires immense computational power from specialized mining hardware globally.
Bitcoin mining uses a lot of electricity, right?
An enormous amount. Estimates vary, but credible sources suggest Bitcoin's POW network currently consumes somewhere around 200 terawatt-hours of electricity annually. To put that in perspective, that's comparable to the total energy consumption of entire medium-sized countries like Thailand or Argentina. Its associated carbon footprint is estimated to be around 114 million tons of CO2 per year, similar to the Czech Republic's. And historically, the trend has generally been towards increasing energy consumption as the network grows and mining difficulty increases.
So critics argue Web3 isn't necessarily greener.
Exactly. Critics argue that Web3, despite its claims of being an evolution, may not be inherently more eco-friendly than Web 2, especially if it relies heavily on energy-intensive consensus protocols and complex infrastructure. It's a major ethical and practical concern. However, there's a crucial counterpoint here, and significant mitigation efforts are underway. Advocates for Bitcoin argue that a substantial and growing portion of Bitcoin mining, perhaps close to 60%, according to the industry's Bitcoin Mining Council, now utilizes sustainable energy sources like hydro, wind, solar, geothermal, or harnesses energy that would otherwise be wasted, like flared natural gas. The veracity of these figures is sometimes debated, but the trend towards greener mining is real.
And what about other blockchains?
More importantly, proof-of-work protocols are rapidly losing popularity for newer blockchains, especially those focused on utility beyond just being digital gold, like smart contract platforms. The most significant move was Ethereum's historic migration from proof-of-work to a proof-of-stake (POS) consensus mechanism in late 2022, an event known as the Merge.
Proof of stake. How is that different?
Proof-of-stake doesn't rely on energy-intensive mining. Instead, network security is maintained by validators who stake or lock up their own cryptocurrency as collateral. It's orders of magnitude, potentially over 99% less energy-intensive than proof-of-work. The energy cost for running an Ethereum validator node is now similar to running a standard laptop. Most new Web3 projects being launched today have adopted some version of proof-of-stake or similar low-energy consensus mechanisms, signaling a very clear and important shift towards more sustainable practices within the broader ecosystem. So, the environmental critique is valid for POW, but less so for the newer POS-based systems that dominate Web3 development now.
Let's dig deeper into security, because when we look at the numbers, the scale of losses from Web3 hacks and exploits is just truly staggering. We're talking billions of dollars lost in some years. That's not just a few isolated incidents or a few bad actors. That feels like a systemic fundamental challenge, doesn't it?
It absolutely is. The Web3 ecosystem faces acute, deeply ingrained security challenges, and the numbers, as you say, are indeed eye-watering. In 2024 alone, estimates put losses from Web3 hacks and scams at a stunning $2.3 billion, spread across hundreds of on-chain security incidents. The first quarter of 2025 saw the crypto industry bleed over $1.64 billion to various hacks and exploits. Decentralized finance, or DeFi protocols, because they often handle large pools of user funds, account for a disproportionately large portion of these losses.
So billions lost, quarter after quarter.
Pretty much. These aren't small, isolated events. They highlight a fundamental difference, a paradigm shift in how security works compared to traditional systems.
How is it fundamentally different?
Traditional security models, think banks, corporate servers, online retailers, rely heavily on centralized control. You have IT teams managing firewalls, banks monitoring for fraud, and crucially, you usually have mechanisms for reversing fraudulent transactions, like credit card chargebacks or banks clawing back mistaken transfers.
Right, there's usually an undo button or someone to call.
Exactly. Web3, by its very design, fundamentally flips this. It operates on distributed consensus across potentially thousands of nodes with no central authority to intervene. And critically, as we've stressed, there's generally no undo button for transactions confirmed on the blockchain. Once it's finalized, it's immutable.
So security isn't about a central firewall.
No. Security in Web3 is primarily about safeguarding the integrity of the network through robust cryptography and ensuring the correctness of the smart contract code. The principle is often stated as code is law. This means that any vulnerability, any bug, any logical flaw in a smart contract's code can have immediate, irreversible financial consequences if exploited. There's no central party to appeal to for a refund or a fix after the fact. And we see attackers exploiting specific types of vulnerabilities over and over again. Some of the most common and devastating attack vectors targeting smart contracts include,
Okay, like what?
first, reentrancy attacks. Imagine that faulty vending machine again, one that lets you keep pulling items out after paying only once because it doesn't register the first withdrawal properly before allowing another. A malicious contract can sometimes recursively call a vulnerable contract's function, like a withdrawal function, multiple times within a single transaction before the vulnerable contract updates its internal balance. This allows the attacker to drain far more funds than they're entitled to. The infamous 2016 hack of the DAO on Ethereum, which resulted in a $50 million loss at the time and led to a highly controversial hard fork of the entire Ethereum blockchain, was a classic reentrancy attack.
Wow, that's what the whole network.
It did. Ethereum Classic still exists as the original chain. Second, flash loan attacks. These are really sophisticated, high-speed, high-stakes financial heists unique to DeFi.
Flash loans. Loans you take out and repay instantly.
Exactly. DeFi protocols allow users to borrow massive amounts of capital, sometimes hundreds of millions of dollars, without any collateral, on the condition that the loan is repaid within the very same blockchain transaction block, which usually takes seconds.
Why would anyone need that?
Legitimate uses include arbitrage or complex trading strategies. But attackers exploit this. They borrow huge sums via a flash loan, use that capital to manipulate the price of an asset on one or more decentralized exchanges, often by messing with the price oracles we'll talk about, execute profitable trades based on that artificial price distortion, and then repay the flash loan, pocketing the difference all within that single atomic transaction. It happens so fast it's hard to stop. We saw examples like the BZX attack back in 2020, $350,000 loss, and the much larger manipulation of Athena's SUSD stablecoin mechanism in 2025, reportedly resulting in $2.2 billion in losses or instability.
Mind-boggling speed and scale.
It is. Third, front-running. This is akin to unethical practices sometimes seen in traditional stock markets. On public blockchains, transactions don't get confirmed instantly. They sit in a public waiting area called the mempool before being picked up by validators.
Okay.
Attackers, often running sophisticated bots, constantly scan this mempool, looking for potentially profitable pending transactions like large buy order for a specific token that will likely push the price up. The attacker quickly submits their own buy order for the same token, but pays a slightly higher gas fee to incentivize validators to process their transaction first, just ahead of the original large order. They buy cheap, the large order executes, driving the price up, and the front-runner immediately sells for a profit, leaving the original user with a worse execution price.
So they jump the queue to profit from your move?
Essentially, yes. It extracts value from ordinary users. Fourth, oracle manipulation. Oracles are crucial pieces of infrastructure. They act as bridges, bringing essential real-world data, like the current price of Bitcoin, or the temperature in Chicago, or the outcome of a sports game, onto the blockchain so that smart contracts can use it.
Like data feeds for the blockchain.
Exactly. But these oracles can become points of failure. Attackers might try to compromise the oracle system itself, or trick it, or find ways to manipulate the underlying data source, like manipulating prices on a low liquidity exchange that the oracle relies on, to feed false information onto the blockchain temporarily. This false data can then be used to exploit other DeFi protocols. For example, an attacker might manipulate an oracle to vastly inflate the reported value of their collateral on a lending platform, allowing them to borrow far more than they should be able to before the oracle price corrects. The huge Mango Markets exploit, resulting in a $100 million loss, involved exactly this kind of oracle price manipulation.
So it sounds like even if the smart contract code itself is perfect, there are still many ways things can go wrong, especially involving human error or deception.
Absolutely. That's a critical point. As the security of the underlying code slowly improves, attackers increasingly shift their focus to exploiting the weakest link, the human element. Social engineering tactics like phishing have become incredibly sophisticated and specifically tailored to the crypto world.
How so?
Attackers create fake websites that perfectly mimic legitimate crypto exchanges or wallet providers. They impersonate project developers or support staff on platforms like Discord or Telegram. They craft elaborate stories or urgent warnings to trick users into revealing their private keys, seed phrases, or approving malicious transactions that drain their wallets. Those rug pulls we mentioned are often based on building false trust and then betraying it. Sophisticated impersonation campaigns are rampant.
And if they get the keys?
It's game over. The stark reality is that your private keys and your seed phrase are the absolute master keys to all your digital assets on that blockchain. If they are compromised through phishing, malware, or even just careless storage, the assets are gone forever. Again, crypto transactions are irreversible. There is no bank to call, no customer service hotline to plead with, no chargeback process to initiate. The immutability of the blockchain, while a feature for trust, becomes devastatingly final if your keys are stolen.
That's terrifying.
It underscores the immense personal responsibility required to operate safely in this space. Furthermore, Web3's borderless, decentralized nature makes effective regulation and law enforcement incredibly difficult. Which jurisdiction applies? Who do you pursue? There's no single entity responsible for policing the entire network or intervening when things go wrong. Compliance for legitimate projects is complex and often lags significantly behind both technological innovation and the evolving tactics of sophisticated criminals. It truly remains, in many respects, a decentralized Wild West when it comes to security and recourse. Hashtag 3.5 societal and economic drawbacks.
We've touched on some really concerning aspects. We often hear so much hype about the potential of the metaverse, these immersive digital worlds. But could spending more time in these highly realistic virtual environments actually be detrimental to our mental health? Perhaps even more so than the problems we already see with current social media platforms.
That's a significant concern being raised by psychologists and social scientists, and it definitely warrants close scrutiny. The highly immersive nature of the metaverse, especially when amplified by VR and AR technologies, could potentially become even more addictive than traditional social media, which is already known to cause issues.
More addictive.
Well, the feeling of presence, of actually being in a different reality, could make it harder to disengage. This might lead to a host of problems, fostering unrealistic life expectations based on curated virtual experiences, triggering unhealthy social comparisons with others' idealized avatars or virtual possessions, leading to increased social withdrawal from the physical world, potential financial issues from overspending on virtual goods or land, and perhaps even fostering paranoid ideations or blurring the lines between reality and simulation for some individuals.
And physical health impacts.
Yes, physically there are concerns too. Potential metaverse addiction could obviously increase sedentary behavior, contributing to obesity and related health problems. Plus, there are worries about severe eye strain and other potential long-term issues from prolonged overuse of VR headsets close to the eyes. There's also a more subtle social pressure risk. Could participation in metaverse-based social events or even professional environments become an expectation, forcing individuals into experiences they find stressful, overwhelming, or damaging, rather than it being a liberating choice? And thinking about AI again, while it promises exponential gains in efficiency and problem solving, it also poses profound potential economic dangers. The most obvious is making vast numbers of current human jobs obsolete across many sectors, from transportation and manufacturing to customer service and even white-collar analytical roles. This could potentially lead to mass unemployment on a scale we've never seen before.
But wouldn't new jobs be created?
Yes, undoubtedly new jobs would be created, particularly in developing, managing, and utilizing AML systems, as well as in the crypto and metaverse sectors themselves. However, there are serious questions about whether these new industries can sustainably employ as many people as are displaced from traditional sectors, and how quickly the workforce can realistically retrain and adapt to these highly specialized new roles. The transition could be incredibly disruptive. And then there are the more extreme, highly theoretical, but still discussed worst-case scenarios involving AI. Scientists, philosophers, and even prominent tech entrepreneurs like Elon Musk have repeatedly warned about the potential long-term risks of developing artificial general intelligence, AGI, or superintelligence that might not share human values.
The Terminator scenario.
Well, maybe not sentient killer robots tomorrow. But the concern is that highly advanced, potentially malevolent, or simply indifferent AIs could disrupt critical systems. They could potentially hack blockchains, manipulate financial markets like stock exchanges, take control of vital infrastructure like power grids or transportation networks, or even gain control of autonomous military hardware. These risks become exponentially greater when you consider the potential power of combining advanced AI with quantum computing. It's considered by some experts to be a genuine, albeit perhaps distant, existential threat to civilization that needs careful consideration and governance now. Then there's that nuanced issue of privacy in a blockchain world and the potential threat of CBDCs. Despite Web3's marketing often emphasizing increased user control and privacy through pseudonymity, the reality is that most public blockchains like Bitcoin and Ethereum record every single transaction in a transparent, permanent, publicly accessible ledger.
Everything is out there.
Pretty much. While your real name isn't directly attached to your wallet address, these addresses are pseudonymous, not truly anonymous. Skilled cybersecurity professionals and chain analysis firms, including those employed by governments and law enforcement, can often use sophisticated techniques to trace transactions, cluster addresses belonging to the same entity, and ultimately link wallet activity back to real-world identities through exchanges or other off-chain data points. This could potentially give governments or corporations access to vast amounts of financial information without needing a traditional warrant. And the immutable nature of blockchains also makes it extremely difficult, if not impossible, for users to ever delete potentially embarrassing, compromising, or simply outdated information about their past activities once it's recorded on-chain. Your digital history is etched in stone. But perhaps the bigger, more immediate privacy concern for many are central bank digital currencies, or CBDCs. Central banks across the globe, from China to Europe to the US, are actively researching and piloting these government-issued digital currencies, often built on blockchain or distributed ledger technology.
How are they different from crypto, like Bitcoin?
Crucially, unlike decentralized cryptocurrencies, CBDCs would be fully centralized and controlled by the government or central bank. They would likely retain the inflationary characteristics of traditional fiat currency, and they would offer few, if any, of the privacy benefits associated with pseudonymous cryptocurrencies. In fact, many experts and privacy advocates warn that CBDCs could create a privacy nightmare.
Why a night?
Because a centralized digital currency could allow governments to track every single transaction you make in real time. They could potentially have the power to freeze your digital wallet, limit your spending on certain goods or services, like sugary drinks or gasoline perhaps, impose negative interest rates directly on your holdings, or even link your financial activity to other databases, potentially enabling systems like China's social credit score. It represents, according to critics, an incredible threat to privacy and an unprecedented level of potential government control over citizens' financial lives, with arguably little upside for users compared to existing digital payment systems. Finally, we simply cannot ignore crypto's inherent market instability and the fundamental critique regarding its lack of real-world productive value. The cryptocurrencies that underpin most of the Web3 ecosystem are significantly more volatile, meaning their prices swing much more wildly than traditional asset classes like stocks or bonds. We've seen multiple major flash crashes where market values have plummeted by huge percentages in short periods. That $1 trillion market cap wipeout in May 2022 is a stark reminder.
Makes it risky for everyday use or saving.
Extremely risky. And influential critics, like legendary investor Warren Buffett, famously argue that assets like Bitcoin are inherently unproductive. They don't generate cash flow, they don't produce goods or services that directly benefit society in the way that, say, a farm or a factory does. Spending millions of dollars on virtual land in the metaverse platform, for instance, provides almost no tangible societal benefit compared to investing that same capital in building real-world housing or funding productive businesses.
The greater fool theory argument.
That's often the critique, yes. That the value relies solely on being able to sell it to someone else for a higher price later. The market is also clearly prone to speculative bubbles and artificial overheating. We saw that with the intense hype around projects like the Bored Ape Yacht Club and its ApeCoin. And the proliferation of highly unstable meme coins, often with no underlying utility or value proposition beyond social media buzz, further fuels skepticism about the market's maturity and rationality. Furthermore, despite all the talk about banking the unbanked, the reality is that crypto and DeFi have yet to widely offer many basic essential financial services to the average person. Things like easily accessible credit cards, affordable student loans, or small-scale home mortgages are still largely absent from the DeFi landscape. Crypto-backed mortgages, where they exist, are generally limited to high-net-worth individuals borrowing against large crypto holdings, often through centralized crypto lenders, not decentralized protocols. The promise of broad financial inclusion, while powerful, still has a long way to go to match the reality on the ground.
Okay, we have definitely covered the ambitious promises and the very real, quite daunting pitfalls and challenges of Web3. So looking forward now, how is this space actually evolving to address these massive challenges? What concrete progress are we seeing? Are solutions maturing, or is this still mostly just experimental?
That's a crucial question, because the space absolutely isn't static. It's iterating and innovating at a breakneck pace. Despite all the challenges we've discussed, significant progress is being made on multiple fronts, particularly in addressing some of the core technical limitations.
Like scalability.
Exactly. Improving blockchain scalability remains a top priority. We're seeing technical improvements directly within the base Layer 1 blockchains themselves, things like exploring novel, more efficient consensus mechanisms beyond traditional POW or POS, and implementing techniques like sharding, which aims to split the blockchain's workload across multiple parallel chains to increase overall transaction throughput. We're also seeing the emergence of specialized, high-performant Layer 1s that are specifically designed from the ground up to prioritize speed and low fees, sometimes at the expense of some decentralization.
And those Layer 2s.
And crucially, yes, those Layer 2 scaling solutions are maturing rapidly. Platforms like Arbitrum, Optimism, Polygon zk-EVM, Starknet, zk-Sync, they're becoming much more robust, user-friendly, and widely adopted. They effectively bundle thousands of transactions together off-chain and then use clever cryptographic techniques like rollups to post compressed proof back to the main Layer 1 chain, achieving dramatically higher speeds and bringing transaction costs down to just pennies or fractions of a penny in many cases. This is making Web3 applications practical for more use cases. The developer ecosystem for Web3 has also matured significantly in recent years. It's becoming easier for developers to actually build things. Major cloud providers like Amazon Web Services, Google Cloud, and Microsoft Azure now offer blockchain infrastructure as a service, essentially allowing enterprises to deploy and manage blockchain nodes and networks much more easily without needing deep in-house expertise in running that core infrastructure.
Lowering the barrier to entry for building.
Precisely. Furthermore, there's now a rich ecosystem of libraries, software frameworks, like Hardhat or Foundry for smart contract development, and software development kits, SDKs, available. These tools significantly accelerate the development process for decentralized applications and other blockchain use cases. It's getting faster and cheaper to build and experiment. In financial applications, we're seeing traditional financial firms becoming much more comfortable, albeit cautiously, with exploring investments in digital assets. This is partly supported by the emergence of improved institutional-grade custody solutions that make it safer for large institutions, like pension funds or asset managers, to hold cryptocurrencies securely.
Big money getting more comfortable.
Gradually, yes. And decentralized finance, DeFi, continues to evolve and innovate, carving out its niche as a potential alternative or complement to traditional financial industry functions, especially, as we noted, for potentially serving underserved populations or offering novel financial products. The adoption of digital assets like NFTs and other crypto tokens is also continuing to open up new avenues for the broader tokenized economy, exploring possibilities like fractional ownership and extending market reach for traditionally illiquid assets like fine art, collectibles, and potentially real estate. And critically, addressing those serious environmental concerns we discussed earlier, there's that strong and continuing shift away from proof of work towards proof of stake, EOS, and other energy-efficient consensus mechanisms. Ethereum's successful merge to POS was a landmark event, proving it could be done at scale and dramatically reducing its energy footprint. Most new Web3 projects being launched today are choosing POS or similar protocols from the outset. This signals a clear and active commitment within the developer community to improving the sustainability profile of the Web3 ecosystem, making the environmental critique less potent for the future of Web3, even if it remains valid for Bitcoin. Hashtag 4.2, considerations for enterprise adoption.
So, if you're a business leader listening right now, maybe intrigued by the potential, but also wary of the risks, and you're grappling with whether or not to actually dive into this Web3 world, what are the absolutely essential strategic questions you need to be asking internally before taking the plunge?
That's exactly the right mindset. Cautious but strategic exploration. For businesses considering a leap into Web3, a set of foundational strategic questions is indeed crucial. First and foremost, is blockchain technology truly a good fit for our company's specific use case or the problem we're trying to solve? It's definitely not a magical solution for every business process.
Don't just use blockchain for blockchain's sake.
Precisely. Avoid the hype cycle. Second, if it is a good fit, should we try to build our own custom solution from the ground up? Should we partner with existing specialized Web3 companies or protocols? Or should we look to buy an off-the-shelf blockchain-based solution if one exists? Each approach has very different implications for cost, control, and time to market.
Build, partner, or buy. Okay.
And critically, third, which specific blockchain protocol or platform should we build on or integrate with? Ethereum, a layer 2, Solana, a private permission chain. The choice of underlying platform has significant long-term consequences.
How do you even begin to answer that first question? Is blockchain a good fit?
Deloitte suggests a simple framework. Companies should ask themselves, are multiple non-trusting parties likely to be involved in the process or workflow we're considering? Is there a genuine need for shared, tamper-proof data that needs to be accessible to multiple independent parties? Is there a strong requirement for immutable accountability and transparent auditability of transactions or records? If the answers to several of these questions are yes, then leveraging blockchain technology might indeed offer significant advantages over traditional databases or centralized systems. If the answer is mostly no, then a blockchain is probably unnecessary complexity. Once you've decided blockchain might be suitable, choosing the right protocol or platform involves evaluating several key factors. Scalability is paramount for most enterprise applications. You need to realistically assess a protocol's transaction throughput capacity, how many transactions per second it can handle, and its typical transaction fees against the anticipated user load and economic model of your specific application. Will it choke under pressure? Will the fees make the use case uneconomical?
Right. Can it handle the volume affordably?
Yes, exactly. Ecosystem adoption is also really important to consider. Which protocols have other companies, perhaps in your industry or facing similar challenges, already adopted? It's wise to look for established ecosystems with strong network effects. High adoption often indicates market trust, maturity, and importantly, allows for potential integration with other existing composable applications on that same chain, letting you leverage work others have already done.
Don't build on a ghost chain.
Precisely. Developer participation is another strong indicator of a protocol's health and long-term viability. Is there a large, active community of developers building on this platform, contributing to its core code, creating tools, and sharing knowledge? Sustained developer activity suggests future advancements and what's called developer mindshare. It attracts top technical talent, which is crucial for building robust applications. And finally, integration readiness is vital, especially for established enterprises. You must assess a protocol's ability and the tools available around it to integrate reasonably smoothly with your existing legacy systems. Things like connecting to traditional financial rails, credit card payments, ACH bank transfers, integrating with robust data analytics platforms, or communicating with users through standard channels like email or text messages. Blockchain solutions rarely exist in complete isolation. They almost always need to talk to the rest of your existing IT infrastructure. But here's the interesting thing.
Despite all these identified challenges, complexities, regulatory uncertainties, and ongoing skepticism, that same recent Deloitte poll found that a significant 87% of the businesses they surveyed indicated they are likely to invest in some form of blockchain solution within the next 12 months.
87%, that's huge, despite all the problems.
It is. It indicates a really robust and continued interest in Web3's perceived relevance and potential value proposition for enterprises. It suggests that while the path forward is clearly not simple or without significant obstacles, the potential upside for efficiency gains, new business models, enhanced transparency, or competitive advantage is seen as compelling enough by a vast majority of businesses to warrant serious investigation and investment. They seem to believe it's not if, but when and how they need to engage with this technology. Hashtag tag 4.3 navigating user safety.
Okay, so we've covered a lot of ground. We've explored the immense potential, the ambitious vision, but also thoroughly examined the very real risks, the scams, the technical hurdles, the critiques. After processing all of this, how can you, our listener, actually navigate this complex and sometimes dangerous decentralized Wild West and stay reasonably safe if you choose to interact with Web3? What are the most important practical steps?
That's perhaps the most crucial question for anyone listening who is curious or already involved. Because ultimately, in this decentralized world, personal responsibility for security is paramount. The most critical steps involve adopting robust personal security hygiene consistently.
Like, what specifically? What's step one?
Step one, arguably, is how you manage your private keys. You should always use hardware wallets, often called cold wallets like Ledger or Trezor devices, for storing any significant amount of cryptocurrency or valuable NFTs. These devices keep your private keys completely offline, isolated from your internet-connected computer or phone, making them virtually impervious to online hacking attempts like malware or phishing attacks that target browser-based hot wallets.
Keep your keys offline. Got it.
Step 2. Enable multi-factor authentication, MFA, sometimes called two-factor authentication, 2FA, on absolutely every account you use that offers it, crypto exchanges, wallet apps, email, social media, and crucially, prioritize using hardware-based MFA, like a YubiKey or security key, or authenticator apps, like Google Authenticator or Authy, over less secure SMS-based MFA, which can be vulnerable to SIM swapping attacks.
Use stronger MFA, not just text messages.
Exactly. Step 3, and this is non-negotiable, never ever share your private keys or your seed phrase, that list of 12 or 24 words, with anyone. Never store it digitally, not in a text file, not in your email drafts, not in a password manager, not in cloud storage. Write it down physically, double-check it, and store it securely in multiple offline locations, like a safe deposit box or hidden securely at home. Its compromise means the irreversible loss of all assets controlled by that key. Treat it like the master key to your entire digital financial life.
Guard that seed phrase with your life.
Pretty much. Beyond these fundamental practices, constant vigilance is required. Always verify the legitimacy of new projects before investing or interacting. Look for credible teams, transparent communication, and ideally independent smart contract audits from reputable security firms. Be intensely skeptical of suspicious links, unsolicited emails, or direct messages offering giveaways or asking for wallet connections. If an offer seems too good to be true, it almost certainly is. And when interacting with new DeFi protocols or dApps for the first time, maybe start with very small transactions to test the waters, understand how it works, and ensure everything behaves as expected before committing significant assets. The Web3 ecosystem, despite its challenges, also has a unique strength: its community and open source nature.
Active participation in open-source security initiatives where developers publicly share and peer-review code is vital for catching vulnerabilities early. Community reporting of scams or suspicious activities helps protect everyone.
A culture of shared vigilance, learning collectively from past hacks and exploits through detailed post-mortem analyses, and contributing to bug bounty programs, where projects financially reward ethical hackers for responsibly disclosing security flaws, helps to progressively fortify the entire network over time. This collaborative security approach is quite different from the closed-source proprietary nature of much of Web 2.0. Finally, it's worth noting that innovative technologies are continuously being developed specifically to enhance Web3 security and privacy. Zero-knowledge proofs, ZKPs, are a fascinating area of cryptography. They allow users to prove that a statement is true, for example, I am over 18 or I have sufficient funds, without revealing the underlying sensitive data itself. ZKPs have huge potential for enhancing privacy in transactions and identity verification, and also for enabling more scalable and private Layer 2 solutions.
Proving something without showing the details. Interesting.
Exactly. Another important technique, especially for critical infrastructure, is formal verification. This isn't just testing. It's a rigorous mathematical process used to prove that a smart contract's code behaves exactly according to its formal specification, ensuring it's free from certain types of logical flaws or unintended behaviors. It's complex and expensive, but essential for high-stakes applications. And decentralized identity, DID solutions, sometimes called self-sovereign identity, SSI, are emerging. These aim to give users much more control over their own digital identity credentials, allowing them to selectively disclose verified information without relying on centralized identity providers like Google or Facebook logins. These technological advancements are crucial for building a safer, more private, and ultimately more trustworthy Web3 infrastructure for the future. #tag outro.
Wow. What a journey through the immense potential and the, frankly, quite significant perils of Web3. It is absolutely clear that this isn't a simple story of just good versus bad or black versus white. It's a really complex, rapidly evolving landscape filled with incredible highs, genuine innovation, but also some very real, very present dangers.
Couldn't agree more. It really is a testament to human ingenuity. On one hand, this constant desire for greater autonomy, efficiency, and new ways to organize ourselves online.
Yeah.
But it's also a stark reminder of the inherent complexities and risks that always accompany exploring new technological frontiers, and a constant critical need for vigilance, skepticism, and careful design.
Yeah, that vigilance part really stands out after the security discussion.
Indeed. We've seen perspectives ranging from the Federal Reserve's quite detailed analysis of its potential financial implications, acknowledging both efficiencies and risks, all the way to the incredibly candid, sometimes brutal criticisms expressed on platforms like Reddit. And then the sobering reality check provided by those multi-billion-dollar security breaches and the ongoing regulatory uncertainty. Web3 clearly presents both a powerful, deeply aspirational vision for a better internet and simultaneously profound, immediate challenges that need to be overcome.
So for you, our listener, after hearing all this, what stands out? I think it's clear that Web3 isn't just some technical upgrade happening in the background. It feels much more like a societal experiment, a huge global debate unfolding in real time about the future of the internet and maybe even ownership itself.
That's a great way to put it, a societal experiment.
It really has the potential to redefine almost everything, from how we bank and invest to how creators earn a living to how we interact in online communities, potentially empowering you with new forms of ownership and control over your digital life. But as we spent a lot of time discussing, it also introduces entirely new categories of risk, sophisticated new forms of fraud, and perhaps paradoxically, even new ways for powerful entities, whether VCs or governments through things like CBDCs, to exert influence or control, potentially undermining the very decentralization it promises.
Which brings us to a really important final thought, perhaps a provocative question for you to consider. The entire promise of Web3, its core appeal, hinges on achieving genuine decentralization, on truly shifting power away from intermediaries and towards the individual user in the community. But we've seen throughout our discussion just how easily that ideal can be diluted by the influence of large capital investments, by complex technical barriers that exclude average users, by the sheer necessity of user-friendly interfaces that might reintroduce centralization, or even by regulatory capture.
So the future isn't set in stone.
Not at all. The future, whether Web3 ultimately leads us towards a genuinely more equitable, efficient, private, and user-owned digital future, or whether it merely shifts power to a new set of players, while creating even more vulnerabilities and complexities. That future ultimately depends on the choices and actions taken now. By individual users like you, by the developers building the protocols, by the businesses choosing to adopt or ignore it, and by the policymakers struggling to regulate it.
It's up to us then.
In many ways, yes. So the question becomes, what steps will you take? How will you engage with this? Will you critically evaluate the claims? Will you demand better security and usability? Will you participate in governance if you have the opportunity? How can you help shape this next iteration of the internet to ensure it truly serves your interests, fosters genuine empowerment, rather than becoming just another system that ultimately controls or exploits its users? That's the challenge and the opportunity ahead for all of us.